Welcome, wonderful geometry students. Today we're looking at isosceles triangles. An isosceles triangle is just a triangle with two equal sides and the base angles also being the same. Notice in this case we have these two sides congruent, right? Congruent is just a word to mean the same. And then we have the base angles which are also the same. That is all an isosceles triangle is. So we look at an example. And it says, consider the isosceles triangle ABC shown below, where AB is equal to AC. And so the vertex angle in this case, the angle in reference here would be angle BAC has been bisected, okay? It has been bisected. Recall what that word means, okay? To bisect an angle means to cut in half, okay? To bisect an angle means to cut in half. So make sure that you remember that. That's going to be very important. Now, what is true about the segments BD and CD? Well, if this is an angle bisector, if AD is an angle bisector, right? Then what is going to be true about these two segments? What is true about these two segments here? Okay, well, those two segments, they're going to be equal, okay? These two segments are equal. And what does that mean? Well, this is how we write that notation. BD is congruent. BD is congruent to CD. Okay, notice that I'm using this symbol. It means congruent. If you wanted to say they were equal, then we would talk about their measures, okay? Their measures, the lengths are equal, but those segments are congruent. Notice the change, the subtle change in language there, okay? So, awesome. Let's move on. Given what we've learned about the previous example, right? Okay, explain why this must be perpendicular. Well, big thing here, big picture. Notice that we have a line, AD, and we have two triangles created by that line. Now, if I were to ask you, well, what type of rigid motion is this? What type of transformation is this? You would say, yes, you with the black shirt, you got it? Yes, it is a reflection, okay? It is a reflection across line or ray AD, okay? So angle B or point B would map to point C, right? Where would point A and D land? Would point A and D change? That's right, of course it wouldn't, because point A and D are both on the line of reflections. Those points are fixed and they do not move. The only points that are going to change are the points on either side of the line of reflection, okay? So B would map onto C. Okay, well, let's continue. If this is a rigid motion, we're supposed to show that these two triangles are going to be congruent, right? They're going to be equal. So far, we have an angle bisector, and now we know these two angles right here. This angle, angle BAD, and angle CAD, they are both congruent. We just talked about that BD is congruent to CD, and they gave us that this is an isosceles triangle, so therefore AB is congruent to AC. Well, so far we have all of those parts are congruent. All of those corresponding parts are congruent. Recall what perpendicular means, okay? Recall that perpendicular means to intersect at a right angle. So that means we need to show that AD intersects BC at a right angle. We need to show that this is 90 degrees and this is 90 degrees, okay? Simple. Look at. Combine these two angles. What do they need to measure up to? These two angles need to measure up to 180 degrees. They're a linear pair, okay? They form 180 degrees. They're supplementary, and we learned about that before. Supplementary. Okay, well, if they're supplementary, and now we know they have to be the same, because the two triangles are congruent, okay? They have to be the same measure. Well, think of two numbers that are the same and add to 180 degrees. Ding, 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 ding. That's true, 90 degrees. Therefore, we have two 90-degree angles. Now, this is a perpendicular line. It is a perpendicular line because it created a 90-degree angle, okay? So, it is a perpendicular. Well, now it's also called a perpendicular bisector, okay? This is going to be called a perpendicular bisector. Why is it a perpendicular bisector? What does a perpendicular bisector do? Well, hey, we're about to construct one. So using a compass and a straight edge, construct a perpendicular bisector, okay? Let's construct a perpendicular bisector. And here we go. First thing to do is take your compass, put your needle on one end of the compass, and make an arc. But first, make sure that you open your compass more than halfway of the segment, okay? It could be up here, it could be out here, it could be here, it could be here. It cannot be here. Just make sure it's more than half. That's appropriate. And let's make an arc somewhere in the center, okay? Let's make an arc somewhere in the center. And you do the same thing on the other side, somewhere in the center, okay? And now flip it and put your needle on the other side. Do not adjust the length of the compass. Do not adjust the radius, okay? Now, there we go. Intersect and intersect on the other side. Done, right there. We're almost done here. All I have to do is create my line, okay? From here, connect those two intersection points. Voila! And I have it. Now, I've created two equal halves, but not only that, I've also created a right angle. Here is a right angle. I have four right angles, okay? There's one. Okay? That is a perpendicular bisector. Two equal halves. This half is equal to this half. Right? Sorry. We have this half is equal to this half. Okay, and I have a 90-degree angle. So, what does a perpendicular bisector do? Well, a perpendicular bisector, okay, ready? A perpendicular bisector does two things. It cuts a segment in half and it creates a right angle. So make sure that you also have that in your notes. A perpendicular bisector does two things, and make sure you write those two things down. Now you have a check for understanding here. And so I'm just going to read the directions for you. Okay, so recall that the sum of all angles in a triangle add to 180. That means that angle A plus angle B plus angle C add to 180 degrees, regardless of how big or small the triangle is, or what type of triangle it is. It could be an isosceles, a scalene, okay, an equilateral. They all add to 180 degrees. Now use that in combination with what's given here, okay? So in triangle ABC, we have that AC is equal to BC. Which two angles must be equal in this isosceles triangle? And lastly, if the measure of angle A is 56, find the measure of angle C. That is all. I will see you in class.